Determine the MACLAURIN'S series expansion for f of x is equal to ln of 1 plus 3x to ascending powers of x up to and including x to power 4. Hence, evaluate the integral from 0 to 1 of 1 over x ln of 1 plus 3x dx. Now, so to expand any function in the MACLAURIN series, the function f of x in the MACLAURIN series, as usual, we start from f of 0, isn't it? So when you want to expand the function f of x in MACLAURIN series, we start from f of 0. So if we differentiate it for the first time, f prime of 0, you leave a space, then plus, you differentiate it for the second time, you leave a space, plus, you differentiate it for the third time, you leave a space, plus, you differentiate it for the fourth time, because we are looking for in ascending powers up to and including x to power 4, isn't it? So if we are including x to power 4, meaning this fourth derivative is what is having x to power 4. Are we together? Is that okay? So, if you have f prime of 0, it means it is over 1 factorial, then x is raised to power that 1, isn't it? If you have double prime 2, then it means it is over 2 factorial, and x is raised to power that 2, isn't it? Are we together? If you have triple prime of 0, it means it is over 3 factorial, then x is raised to power that 3. If you have fourth derivative, meaning it is over 4 factorial, then x is raised to power that 4. So this is the MACLAURIN series they require of this given function, isn't it? Are we together? So let us start. F of x, you've been told is, let us start by doing it this side. So we have f of x, we've been given to be ln of 1 plus 3x, isn't it? Yes. So we have to differentiate this f of x until we get to the fourth derivative, isn't it? Remember when you are differentiating an ln function, so if we differentiate f of x for the first time, you get 3 over 1 plus 3x. Are we together? Yes. Because when you have y to be equals to ln of x, if you differentiate y, you are supposed to get 1 over x, isn't it? Are we together? Meaning, when you have y to be equal to ln of 2x, if you differentiate y, you get 1 over what is inside, meaning 1 over 2x. That is outer function, isn't it? It's when you now differentiate 2x. If you differentiate 2x, you get 2, and you get the product of the inner and the outer function, isn't it? So that at the end you get 2 over 2x, which is 1 over x, isn't it? So in this case, we had maybe y to be ln of 1 plus 3x. So if you differentiate y, it is 1 over what is inside ln. The imperial logarithm, what is inside is 1 plus 3x. You differentiated the outer function, isn't it? That is when you now differentiate the inner function. So the inner function, if you differentiate 1, you get 0. If you differentiate 3x, you get 3. So if you multiply the 2, 1 times 3, you get 3 over 1 plus 3x. So this is 3 over 1, isn't it? Are we together? So that is how to differentiate the natural log. Having done that, we now get f double prime of x. What is f double prime of x here? If you differentiate this, what do you get? Some of them you just see. What do you get? I can see it is negative 9 over 1 plus 3x squared. Some of these things you don't need to do. They're just things you see. So look at this, 3 over 1 plus 3x. That means it is 3. If you have 3 over 1 plus 3x, this can be written in the form 3 into 1 plus 3x raised to negative 1. You see that negative 1 means reciprocal. Are you seeing that? Meaning you removed in the denominator. So 3 over 1 plus 3x can be expressed like this. 1 plus 3x in the denominator, if you bring in the numerator, raised to negative 1 to imply reciprocal, isn't it? So from here, if you say this is your function y, if you differentiate y, it is the power rule. Negative 1 times 3, so you get negative 3, isn't it? Then into 1 plus 3x. That is an inner function if you make the way it is. This 1 plus 3x can even be t. Chain rule, isn't it? So t raised to negative 1. So it is negative 1 times 3. You get negative 3, then you reduce the power by 1. Negative 1 minus 1, so you now get negative 2. Are we together? Because what is inside here, 1 plus 3x, you can even let it to be t, so that you have 3t raised to negative 1. If you differentiate this, negative 1 times 3 is negative 3, then your t, you reduce the power by 1, you get raised to negative 2. Are you seeing that? Then your t was that. Are we together? That one you are done with the outer function, isn't it? Then you go to the inner function, the t itself, 1 plus 3x. If you differentiate 1 plus 3x, you get what? If you differentiate what is inside, so what is inside is 1 plus 3x. And when you differentiate once, you get 0. If you differentiate 3x, you get 3. See, then you multiply the outer function. This one is the derivative of the outer function times the derivative of the inner function. Chain rule, isn't it? So what do you get? Negative 3 times 3, so you get negative 9. Then here we have 1 plus 3x raised to negative 2. This negative means it is in the denominator, a reciprocal. Are you seeing how it is simple to be dealt with? Are we together? Good. After that, we go to f triple prime of x. You can now see them, isn't it? So f triple prime of x, give me the answer. F triple prime of x you cannot see. That guy at the corner, at the back. Because I'm seeing somebody said it is 54. 54 over 1 plus 3x cubed. Jojo? Very simple. Look here. We have here, if you let your y to be negative 9, when you have over 1 plus 3x squared, it means it is 1 plus 3x raised to negative 2. That negative means it is the reciprocal, but the power remains the way it was, isn't it? Are we together? See, negative 9 over 1 plus 3x squared can be written in this form. This negative means it is in the denominator, isn't it? This negative only. Remember, if you have 1 over 1 plus 3x raised to square here, this 1 plus 3x, it remains this way it is squared. The power does not change. You only put the negative to show that it is the reciprocal. Are you seeing that? Are we together? Lots of indices. So from here, we've now written in a form we can differentiate, isn't it? So when you are now differentiating y, you start with the outer function. This 1 plus 3x, you can even say it is t, isn't it? So it's like t raised to negative 2. Are we together? So if you're differentiating t raised to negative 2, it is the power times the coefficient. Are you seeing that? The power. So negative 2 times negative 9, so you get 18. Then your t is 1 plus 3x. This is t. The inner function we are still not interested in. It's still t, isn't it? Then you reduce the power by 1. Negative 2 minus 1, so you now get negative 3. See, negative 2 minus 1 is negative 3. See, you differentiated the outer function, where I'm saying this 1 plus 3x will learn to be t, so that you have maybe negative 9t raised to negative 2. If you differentiate this, you get negative 2 times negative 9. So you get 18, then you reduce the power of t by 1. Negative 2 minus 1 is negative 3. Then that our t is the value 1 plus 3x. Are we together? You are done with the outer function. Then you now differentiate the inner function. What was t? Your t was 1 plus 3x. See, that is the inner function. So if you differentiate 1 plus 3x, what do you get? If you differentiate 1, you get 0. If you differentiate 3x, you get 3. Then it is the product of the outer function times the inner function. So 3 times 18, 54. So we now have here 54 into 1 plus 3x raised to negative 3, isn't it? This negative means this term, the way it is in the denominator, isn't it? So it means here you have 54 is in the numerator, then your 1 plus 3x cubed. The power remains the way it is, only negative source reciprocal, isn't it? And that is exactly what we have here. Are you seeing how they are simple? So are you seeing the reason why you paid much attention when you were doing that class? Because that class, we are applying it in everything, up to the engineering mathematics 3. The whole of that class, isn't it? Are we together? Yes. So you've done that. Then we are now looking for the last one. We have to get the fourth derivative, isn't it? If we differentiate this triple third derivative, we get the, yeah. So f, fourth derivative of x, what is the answer? Negative 4? 400 and? Negative 486 over to power 4. Very good, isn't it? Yes, because you have negative 9 times 54, isn't it? Are we together? I like that. You can now see it very clearly from the back, isn't it? Isn't it? Good. Now, having found all this, we don't need this. What do we need? We need f of 0, we need f prime of 0, we need f double prime of 0, we need f triple prime of 0 in that order, isn't it? So let us start with the first one. If we have f of x, we can get f of 0, isn't it? Meaning where there is x, you put 0. Are you seeing that? So where there is x, if you put 0, so you have a line of 1 plus 3, 0. 3 times 0 is 0. So that is a line of 1. What is a line of 1? What is a line of 1? The natural log. The logarithm of 1 to any base is always 0. We dealt with that in indices and logarithms. What is a line of 1? 0. The other guys are not having calculated. Huh? It's good for you. It's good for f prime of 0. We are looking for this, f prime of 0. Where there is x, you put 0. So that we have f prime of 0, isn't it? You see that? 0. So we are going to have 3 over 1 plus 3 times 0 is 0. See, that is just 3 over 1. So you get f prime of 0 to be what? See, 3. Where there is x is where you put 0, so that you have f prime of 0. So if this is 0, meaning this is not there, you are remaining with 3 over 1, which is 3, isn't it? Are we together? Yes. I go to the next one. F double prime of 0. We are looking for this term. F double prime of 0. So f double prime of 0 meaning where there is x, you put 0, isn't it? So we have 3 times 0 is 0. So we have 1 squared is just 1, isn't it? So negative 9 over 1 is just negative 9. And you are done with that term. Are we together? We go to the next one. Here, f triple prime of 0. We are looking for this term, isn't it? F triple prime of 0. Where there is x, you put 0, so that you have f triple prime of 0, isn't it? So f triple prime of 0, x is 0, so here you remain with 1 cube. See, that is just 1. So 54 over 1 is just 54. Very good. You move to the next one. The f fourth derivative of 0. Where there is x, put 0. So you have 1 raised to power 4, isn't it? So that is 1. So negative 486 over 1 is negative 486. So have you seen you found f of 0, f prime of 0, f double prime of 0, f triple prime of 0, and f the fourth derivative of 0, isn't it? And you get that. So what we are now doing is substituting everything in our equation, isn't it? So you start, what is f of x? You are substituting everything. F of x from here is what? ln of 1 plus 3x. We are substituting everything in the formula, isn't it? F of x is given as 1 plus ln of 1 plus 3x. So where there is f of x, we put its value, it is ln of 1 plus 3x. To be equals to what? Start. F of 0 is 0, meaning this term is 0. It is not there, isn't it? Are we together? Then you move, f prime of 0 is 3, isn't it? See, this is 3. So 3 over 1 factorial, see, that is just 3. Times x raised to power 1, see, that is 3x. Because x raised to power 1 is just x, isn't it? Are we together? Yes. We are done with this term. We move to the third term. So the third term, f double prime of 0, you found to be negative 9. So go to the counter, negative 9 over 2 factorial. That is negative 9 over 2. Negative 9 over 2 factorial is negative 9 over 2, isn't it? Because 2 factorial is just 2, isn't it? Negative 9 over 2 factorial times x squared, so you get negative 9 over 2x squared. Are we together? Ladies and gentlemen, terms of Adam and Eve. So you move to the next one. F triple prime of 0. You found it to be 54. So what is 54 over 3 factorial? Calculator. 54 over 3 factorial. You have? Yeah? You have 9, isn't it? Because 3 factorial is 6, isn't it? Very good. So that is 9x cubed, isn't it? It is plus 9x cubed plus 9x cubed, isn't it? Move to the next one. What is f fourth derivative of 0? What did you get? Negative 486. So negative 486 over 4 factorial. Some of you don't have the calculator. They are not doing this thing. So you have? Negative 81 over 4. So negative 81 over 4 times x raised to power 4, isn't it? Negative 81 over 4, then it is times x raised to power 4. So you see, you substituted everything. So it means you found the MACLAURIN series expansion of ln of 1 plus x to be this. Are we together? You've expanded ln of 1 plus 3x in MACLAURIN series, and this is what we found. Is that okay? Now, having found the MACLAURIN series of this function, you've been told to use it to evaluate this integral. Are you seeing that? The integral you want to evaluate, we have the limits from 0 to 1 over x times ln of 1 plus 3x dx. So what you do is to just substitute the value of ln of 1 plus 3x, isn't it? Are we together? We've been told to evaluate this integral with this series. So it means we are now integrating from 0 to 1. Then outside here we have 1 over x. Then inside, what is ln of 1 plus 3x? ln of 1 plus 3x you found to be this in the MACLAURIN series, isn't it? So where there is ln of 1 plus 3x, you put its value. Are you seeing that? What is its value? Its value is 3x minus 9 over 2x squared plus 9x cubed minus 81 over 4 x raised to power 4. You close the bracket, then outside we have the x. We've only substituted the value of 1 plus, the value of ln of 1 plus 3x. Can you see? Because the value of ln of 1 plus 3x we found to be this in MACLAURIN series. So where there is ln of 1 plus 3x, we put its value, which we substituted there. Are we together? Is that okay? Is that understood? Yes. So the next thing you do is just to simplify, isn't it? When you have 1 over x outside the bracket, it means this 1 over x which is outside, it multiplies everything inside the bracket. It is the common factor outside, isn't it? Are we together? We have to simplify is when we can integrate. So can you multiply everything outside the bracket? The thing outside the bracket multiply everything inside. So when you have 1 over x times 3x, see x is in the denominator. Meaning 1 over x is like you are dividing everything by x, isn't it? See, that is what it means. It's like you are dividing everything by x. So 1 over x times 3x, meaning you are dividing by x. You remain with 3. 1 over x times negative 9 over x squared. Negative 9 over 2x, meaning you are just dividing everything by x, isn't it? Then here, plus 9x squared, if you divide x cubed by x, isn't it? Are we together? Then this times that, minus 81 over 4x, x cubed, if you divide x raised to power 4 by x, isn't it? So this is now what we are integrating. So if you look at what we are integrating, that is a polynomial, isn't it? Are we together? And integrating a polynomial is always the simplest. What do? When you are integrating a polynomial, if you have x raised to power n, you want to integrate. So you simply add 1 to the power, then you divide by the resultant power. See, that's how to deal with the polynomial. Are we together? So can we now start integrating here? If you integrate 3, what do you get? 3x with respect to x, because 3 is like saying 3x raised to power 0. That's why x is silent, because it's raised to power 0, isn't it? So you simply add 1 to the power and you divide by that resultant power. 1 plus 0 is 1 over 1. So you get 3x. Are we together? Go to this other one. Remember, constant we are not interested in. This is the variable we are interested in polynomial when we are integrating a polynomial, isn't it? X raised to power 1, if you integrate x raised to power 1, see, you add 1 to that power. So you now get x raised to power 2 over 2. Are we together? So x raised to power 2 over 2, here we have negative 9 over 2. What will you have? You have negative 9 over 2, then if you integrate x, you get x squared over 2. So you get negative 9 over 4x squared, because 2 times 2 is 4, isn't it? You go to the next one, here we have plus 9. If you integrate x squared, so you get x cubed over 3. So you simply add 1 to the power, and you divide by that resultant power, isn't it? Are we together? Then 9 is a constant. So you now see out there, 9 divided by 3, what do you have? 3x cubed, isn't it? So there you have plus 3x cubed. you move to the next term. The next term is this, isn't it? Minus 81 over minus 81 over 4. Then if you integrate x cubed, so you add 1 to the power, you get x raised to power 4 over. Then here you now see negative 81 over 4 divided by 4. Or it is just negative 81, then 4 times 4 in the denominator. Still the same thing, isn't it? Are we together? So that is negative 81 over 16. So here we have negative 81 over 16 x raised to power 4. Are you seeing the way I'm doing it procedurally so that we don't mess up at any step, isn't it? Then at the end of integration, because it is definite, we don't have arbitrary integration constant, it is definite, isn't it? We put the limits of integration. Are we together? We put the limits of integration. So as usual, when you are evaluating this, it is the upper limit minus the lower limit. So the upper limit is 1. Where there is x, put 1. What do you get? Will be the answer of upper limit. Where there is x, lower limit, you put 0. When you put 0, you see everything will go to 0. So it is going to be upper limit minus lower limit. And you can see lower limit is 0, isn't it? So when you substitute 0 where there is x, see all these are going to go to 0. Meaning the lower limit is 0. So what about upper limit? 1. Because it is upper limit minus lower limit. Where there is 1, x, if you put 1 raised to any power is just 1, isn't it? Meaning 1 squared is 1, 1 here is 1 squared is 1 cubed is 1 cubed is 1. So it's like you're going to remain with 3 minus 9 over 4, isn't it? Are we together? 3 minus 9 over 4 plus 3 minus 81 over 16. What do you get? 3 minus 9 over 4 plus 3 minus 81 over 16. Calculator. You're looking for the value. Negative 20. We have negative 21 over 16 there. Another person. What do you have? Negative 21 over. He also has negative 21 over 16. Another person. This is 4. 4 times 9 is 36. Can you give me 36 plus 81? What is 36 plus 81? 117 over 16 minus 6. 6. That is 6. 6 times 4? No, 6 times 16. 6 times 16 is? 96 over 16. 96 minus 117? Negative. 96 minus 117? Negative 21 over 16. That is the right thing, isn't it? So after that, we now have the final answer, negative 21 over 16 minus 0. You end up with the negative 21 over 16, isn't it? That is your final answer. You've evaluated the integral using the expansion from the MACLAURIN'S series. Are we together? Are we together? Good.